Dear students, so now I am going to discuss air conditioning systems. It is also called as ACs. So it is the next part, continuation of module 5, which I have discussed in the last class. So what do you mean by air conditioning? You have basically come across these things. ACs have been installed in offices and even in the homes, hospitals and all. So first of all, how do we define air conditioning system? So air conditioning system is defined as a device which provides a cool indoor atmosphere at all times regardless of weather conditions. Okay, so it will cool the indoor atmosphere at all times regardless of weather conditions, required either for human comfort or industrial purposes by artificially cooling, humidifying or dehumidifying, cleaning and recirculating the surrounding air. Okay, so what it will do, air conditioning which controls the temperature of the air. Okay, so regardless of weather conditions outside, whether it is summer or winter, whatever it may be, it controls the temperature of air which is required for human comfort. Okay, so human comfort and also for industrial purposes. How we control the temperature of the air? By, so it controls by artificially, suppose it is outside higher temperature, so what it will do, it will cool the air. And humidifying, if the air outside air is dry, then we need to humidify it. Or suppose it is more moisture content in the air, then dehumidification is required. And also it cleans and recirculates the surrounding air. Okay, so it will draws the amount of air from the room, then it will cools down, or suppose if it is hot, it will cools down and filters it, and again clean air will be recirculated back to the room. Okay, so this is what air conditioning. So next, moving to classification. So these air conditioning systems are classified into two main categories. One is comfort air conditioning and one more is industrial air conditioning. So what is comfort? Come to here. Yeah, comfort air conditioning and industrial air conditioning. So in comfort air conditioning, the air is artificially cooled and conditioned to provide maximum comfort to human being. This is called as comfort air conditioning. Okay, so you can see here, aims to provide human comfort in a given space. So again, comfort air conditioning is divided into two categories. One is summer air conditioning and the one more is winter air conditioning. Okay, summer air conditioning aims to provide comfort in summer season, so this is in winter season. Next one is industrial air conditioning. So what is industrial air conditioning? So it provides a controlled atmosphere required in some manufacturing and processing industries, is called industrial air conditioning. So it is aims to provide a suitable environment for carrying out a certain processes. Okay, so in the industries, so that is industrial air conditioning. Next, moving to one by one. So all these are important. So first one is summer air conditioning. So in summer air conditioning, again we have two category. So first I will discuss summer air conditioning for hot and humid outdoor conditions. Okay, so hot and humid outdoor conditions. So this is the diagram. Okay, so this is the diagram, device process diagram, and this is the process is represented on psychometric chart. Okay, now you can see summer air conditioning for hot and humid outdoor conditions. Okay, so now it consists of damper, and this is air filter. Next is heating coil, cooling coil, next one is heating coil, and finally air goes out. So here 1 is inlet and 2 is before entering on the cooling coil, 3 is surface temperature of cooling coil, next fifth one surface temperature of heating coil, 0.4 is finally exit of the conditioned air. Okay, so now let us see what is the how it works. So this type of conditioning process is used in those places where the atmospheric temperature is higher than the comfort temperature. Okay, and also the moisture content in the air is more, so in those places this type of air conditioning is used. Okay, so in these conditions the hot and humid air must be cooled to temperatures lower than the dew point temperature. So what we need to do is, so the temperature of the air is cooled to temperature which is lower than the dew point temperature, so the water vapor in the air can be removed by condensation. Okay, and the resulting cold and dehumidified air is supplied to the conditioned space. So what we do, then the resulting air will be supplied to the conditioned room. Next, so let us see the working principle. So what happens, the air is drawn, means air is enters at condition 1 enters the damper. First it will enters over the damper. So what is damper? It is a valve or a plate that stops or regulates the flow of air inside a duct. Okay, so it will regulates the flow of air inside a duct. So this is the duct, you can see. Next, so after passing through the damper, air passes through air filter. So what is the function of air filter? So air filter removes any dust particles, odor and toxic gases are removed in the air filter. Next, the air passes over the cooling and dehumidification takes place. So in the next stage, what happens here? Cooling and dehumidification takes place and moist air reaches to condition 2. What happens here? Due to cooling power, when it is passed over the cooling coil, so the temperature of the air decreases, so which leads to condensation process, and the humidity moisture content in the air has been removed here, and the finally it will goes to 0.2. You can see here what is happening from 1 to 2. You can see the arrow mark here. 1 to 2, that is cooling as well as dehumidification is taking place with the help of this cooling coil. Okay, so then after that what happens, if you pass this from the condition 2, the cooled and dehumidified air is passed over the heating coil. Why we need to pass over the heating coil is during the process of cooling and dehumidification, the temperature, means the required temperature at 4 will be reduced or will be lower than the required temperature of the 4. So to maintain the required temperature, so after cooling and dehumidification, once again it is passed over heating coil. So once again it is passed over heating coil and the required temperature is achieved here. Okay, so you can see here 1 to 2 is cooling and dehumidification, then 2 to 4 is the again heating, that is sensible heating. So what is sensible heating? Heating of air without adding any moisture. Okay, humidity remains constant. So now, so this is the at final condition 4, air leaves to the space where we require the air conditioning. And you can ask, so what is this 0.5 here and what is this 0.3? So here, maybe if you remember, I have explained the bypass factor. So what is this? So 0.3 is the bypass factor of cooling coil and 0.5 is the bypass factor of heating coil. So 5 is the surface temperature of heating coil and 3 is the surface temperature of cooling coil. So now the process starts from 1, goes to 3, and at 4 it will ends. So this is the working principle of summer air conditioning for hot and humid outdoor conditions. Okay, understood? Next moving to summer air conditioning for hot and dry outdoor conditions. So till now we have discussed it for hot and humid outdoor condition. So dry means moisture is less, or outside the atmosphere air is less moisture and it is dry. So for this condition we have the next device, so that is for summer air conditioning device for hot and dry outdoor condition. So here what we have to do, see here, in this type of conditioning process, it is used in the places where the atmospheric temperature is higher than the comfort temperature with low moisture content. If the atmospheric air is having low moisture content or environmental low moisture content, then this type of air conditioning is used. Air conditioning systems for such hot and dry climates also required cooling of air below the ambient temperature, and removing means in this dry condition we need to add the water content or moisture to the air. Okay, so how we do this one, let us see the working principle before seeing that working. So what are the parts we are having? Like same damper, air filter, first is cooling coil, then due to this is a makeup or a pump, so here water has been sprayed to humidify the air, dry air. Next, so water eliminator, then finally to the conditioned space. Okay, so what happens here at condition 1, so moist air enters at condition 1, it will pass over the damper. Okay, then it is passed once again over through the air filter. After air damper, then it is passed over air filter, so their toxins, odor and dust particles have been removed. Okay, now it is passed over cooling coil. The temperature of the air reduced to condition 2 in the cooling coil, and then so you can see here, so 1 to 2, what is happening, this is a horizontal line, sensible cooling is taking place, sensible cooling, no removal of moisture. So what is the difference between this cooling coil and this cooling coil is, you can see here there is a water, and here process 1 to 2 is represented inclined manner. What it denotes, this is not sensible cooling, this is cooling and dehumidifying. Okay, specific humidity is decreasing, but here so what is happening, it's an horizontal line, means sensible cooling is taking place without removing any moisture. Okay, so next, so after this, so what happens, the whatever cooled air will be entered through adiabatic humidifier. So what happens here, water is being sprayed to the means cooled air. So what happens, it will absorb the moisture, so the air will absorb the moisture and its humidity will increase. You can see here, this is the initial humidity, and now it is going to 0.4, that is humidity has been increased in the, but in the air means humidity of air has been increased. So the air now enters the conditioned space through the water eliminator. This is, so here you can see, so what happens finally after humidification, so this point is here, the exit, so it is passed through water eliminator. Why we want this one is, if any water molecules present in the means air or cooled air, so that has been eliminated here. Then the finally the conditioned air has been sent to room. So what happens here? I'll explain again. So air is drawn through damper, then it is passed through air filter to remove the dust, odor or any toxic gases, and then next process is sensible cooling, so that is represented from 1 to 2. Then here adiabatic humidification, adding the moisture to the air, so that is represented by 2 to 4. Also what is happening here? So you can see it is line is going towards left and slightly up, means moisture content is increasing and the air is again it is getting cooled. Okay, so then it is finally passed through water eliminator. If any moisture water droplet content that has been eliminated, then finally conditioned air is passed through the space where we require the cooling. So this is point 4. Here process is represented by 1 to 2, 2 to 4. Then what is this 3? 3 is the bypass factor of this heating coil. So this is the surface temperature of heating coil, this one. If you draw vertically line, you will get the surface temperature of the heating coil. Okay, so this is about summer air conditioning for hot and dry outdoor conditions. Next moving to winter air conditioning. So during winter, what is the season? So during winter, obviously the outside temperature will be, atmospheric temperature is less and the air is dry. Okay, so in winter air conditioning system is used in such a conditions where the moist air is cold and dry. Okay, in this condition what we need to do, we need to heat. Since it is cold, so we need to heat first, then it is a dry, so we need to add the moisture to that air, then finally we will get the required air for at human comfort. So what happens here? So moist air at condition 1 enters the damper, passes through filter next. So again same function, any dust and odor have been removed, and then it is passed over heating coil 1. You can see here there is one heating coil and second heating coil is there at 7. So 2 heating coil 1, at 7 heating coil 2, and here water sprayer means adiabatic humidification. This is water eliminator. Then again at 6 the conditioned air has been sent to the place. So what happens here? Whatever air, moist and dry air which is coming here is passed over what? Heating coil. So it is passed over heating coil 1 because it is the temperature of the air is low, the temperature has been increased here. You can see here from 1 to 3 is sensible heating. 1 to 3 is sensible heating. Then what is this 2? Bypass factor of heating coil 2 means at surface temperature of the heating coil. Next, what is happening from 3 to 5? You can see from 3 to 5. So we have humidifying the air. By spraying the water, the dry air has been humidified. So meanwhile what happens? You can see there is an inclination here because if we supply water at lower temperature, again its temperature will decreases. The air temperature will decrease. So 1 to 3 we have heated, that is sensible heating. 3 to 4 is humidification with some cooling effect. Okay, so then what happens from 5 to 6? 5 to 6 is sensible heating. Why we need to do this one? You can see here. See, in the first case we have heated the cold air, then its temperature increased due to supply of moisturizing or adiabatic humidification. Its temperature further slightly drops. So whatever the temperature drop in here is being increased with the help of this heating coil too. Okay, so finally, so after here it is passed over this eliminator. Okay, so water eliminator, then finally it is passed over heating coil and the required condition is achieved, and this is finally enters to the condition space at 6. Okay, you can see here this one 1 to 3, then 3 to 5 and 5 to 6 is the process carried out in winter air conditioning. Okay, so now what is this 0.2 heating coil bypass factor or surface temperature of heating coil, and what is this 4, that is the dew point temperature of this surface, sprayed surface. Next, and the 7 is the surface temperature of heating coil 2. Okay, so the condition there of the bypass factor is, if it is a bypass factor of the reheater is 0, then this point will comes. Okay, so this is about winter air conditioning. Hope it is understood. So I will repeat this one: 1 to 3 sensible heating, 3 to 5 cooling and humidification, 5 to 6 is the again sensible heating, then finally it is sent to required space. This is the working principle of winter air conditioning system. And the last topic here is cooling towers in air conditioning systems. So what is cooling tower? Cooling towers are the towers which are usually used in central air conditioning systems in order to cool the warm water delivered from the condenser. Okay, so what is the function of condenser? Condenser absorbs the heat from the flowing fluid or the refrigerant. So then again it is to be cooled and recirculated back to the condenser. So what happens here? In air conditioning systems, the heat absorbed by the refrigerant is rejected to the cold water or condenser. Okay, the warm water from the condenser is pumped to the top of the cooling tower where the water distribution system is installed. Okay, so you can see here the cooling tower consists of, this is masonry construction will be there, and this is a pipe with nozzles, and this is fill material, and the dryer is passed from the down to up, and this is sprayer. So the water from the hot water from the condenser is passed through this pipe and sprayed over in the opposite direction to that of the dry air which is entering. So what happens here? The warm water is distributed through nozzle on the fill media. So what happens if you distribute on the fill media, which slows the water flowing down so as to expose maximum amount of water surface area possible for the best air water contact. So at the same time air drawn through the air inlet. Okay, then what happens? So from the air, so whatever hot water coming from the sprayed through the nozzle is being passed over the fill material. Fill material means, so this is a material which slows the movement of the water down. Okay, so then the dry air is passed from the downward side, means opposite to the water flow. What happens? The air absorbs the heat from the from the water which is coming down, and also it becomes some moist, and also it will absorb some heat and it will escape through this channel. Okay, it will escape. So why it will escape? So whatever air is going here which is comes in contact with hot water, so it gets heated up and also moisture will increase and it loses its density and it will escapes. Okay, so what happens to this water? So hot water gives heat to the dry air and it becomes cool. Means condensation begins, so that condensed water will be collected here, or cold water then again sent back to condenser. Okay, also working is simple. So hot water from the condenser is passed through the spray nozzles, then your fan is there. Okay, so that fine I will explain later. So spray nozzle, when the hot water is sprayed, the dry air which is at lower temperature, which comes in contact with the hot water in the fill material section, so it absorbs heat from the hot water, then the air has been escaped through this moist, so warm and moist air has been escaped through this with the help of the fan. As well as in natural cooling tower, so the air will automatically escapes due to density difference also. Here fan is used, forced sucking of the air. Okay, so by in this way the cooling has been done to the condenser water which is coming out. Then again after cooling, the cooling water which is collected at the bottom has been sent to condenser for further purposes. So this is the working principle of cooling towers in air conditioning systems.